Good morning. I am welcoming back you in the SciLab course, that is EG1308 Matrix Algebra through SciLab as an elective course. Okay, so let's start the SciLab. Okay, so in up to previous lectures we have discussed about several operations on matrix. At the end we have discussed the size of the matrix and determinant and pointwise multiplication, scalar regular matrix multiplication, pointwise division and division of two matrices if possible, because that may not possible all the time. Okay, in this session we are going to discuss about the RRE form and its applications in this matrix. Let me say A, B, 1, 2, 3, 4, 5, 6, 1, 2, 1. So first of all, I want to perform the RRE process of these. So let me go for RREF of A. That is the command to find the RRE form of A, and here it is all the entries in diagonal 1 or except that all others are 0. From this I can conclude that your matrix is invertible. Okay. Let me go for the another matrix B. 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Okay, so you can see that this matrix is invertible or not via multiple ways. For example, determinant of B, it is 0, so it is not invertible. But you can perform that also via this method, the ternary form of B, and at the end you are getting all entries 0 in the last row, means also it says that matrix B is not invertible. So this is another way to find that matrix is invertible or not. Now I want to perform the matrix A is inverse using the RRE form. So let me say first of all C be the E by E identity matrix of 3 by 3. Now in I am first of all considering D as A, adding the this 3 by 3 matrix, that the identity matrix has here, means I am performing the augmented matrix. So how to perform that? So you know that for adding rows, adding columns, we have to perform matrix operation in this way: D in bracket colon comma fourth to sixth columns are entries from C. So let me write C. Correct. Now what I want to perform, that D is now this new matrix. I want to perform RRE form of D. So RRE form of D is this one, and that was obtained from A. Okay, yes. Now what I want to do is I want to remove these first three columns. So first of all I have to store RRE form of D as some another matrix. Let me say E. Then I will remove the first three columns, that is first to third columns, and command for doing that is this: E in bracket colon comma 1 2 3 bracket complete is equals to the empty matrix. So it will remove the first three columns. Now you know that you can perform the inverse of matrix in another way also. Let me say I and V of A. So yes, that is what we are expecting, that finding the inverse of the matrix using the RRE process, and we are getting the exactly same matrix. Okay, let me go for something else. If you want to solve some linear equations, then also you know that you can perform that process in using RRE process. Okay, so let me go for that also. Let me have another matrix G B, the coefficient matrix of the linear equations given to you. So let me say that is x plus 2y plus 4z is equals to 9, then 2x plus 4y minus 3z is equals to 5, then 2x minus 4y plus 5z is equals to 3, and the corresponding coefficient matrix is this one. Now go for RREF of A, sorry, RREF of G. So you know that this center, that is 1.409090, this is the value of x. 1.431818 is the value of y, and 1.1818182 is the value of z. So using the SciLab, you can solve linear equations as you have done in the regular practice course of matrix algebra. Okay. So we have learned two things in this session, that finding the inverse using the RRE process, and finding the solution of linear equations using RRE process. So here I am stopping this session. You perform several matrix operations like this, means find the inverse of several matrices and find the solution of several linear equations, and I hope that you will enjoy this. Stay at home, stay safe. Thank you.